All right. Let's see if this works. According to my end, I should be live now. Looks like maybe it's finally working. Have I sorted out how things work in YouTube? Yeah, if someone could maybe post in Slack or say something in chat. I guess you can see me. It works. Wow, I can't believe it. Excellent. Yeah, so finally I've sorted out the series of steps to get a scheduled YouTube live stream to start approximately on time. So good, everyone can see, and that's good stuff. I guess you can see my desktop here, and I think the plan for today, at least for now, is I have a few things that were suggested as topics that we could review, so we can do that. And if you have other suggestions of things that you might like to go over, we can also do that. And I would just ask maybe that you post in the Slack channel something there. So I think what we can start with is maybe a little bit of review of stuff from exercise number 3. And this has to do with the conditional statements and for loops. I guess conditional statements sound like maybe they were a bit easier to understand the concept than some of the for loop stuff, and so we can go over that a little bit. In fact, what we'll do maybe is go through one of the problems together so you can see how I would solve it, and maybe I'll get a solution that is the expected solution, or maybe not. I didn't actually make this particular problem in the exercise, so I've not tried to do it previously, but we'll do it live and see how this goes. And otherwise, we'll talk maybe a little bit about functions and maybe some of the cases in which you would want to use a function, how you would define it, where you should define it in a code or a Jupyter notebook, and maybe also some examples of like functions that call other functions. So we'll do kind of a little bit of review, I guess, for lessons 3 and 4 today, and that's the kind of tentative plan, and we'll see how that goes. So here is, I guess this is actually problem 4. I'm looking for problem 3 in exercise number 3. So I think most people have gone through and done exercise 3 as far as I understand. Maybe not everybody. And if you haven't yet done it, I guess maybe this will be good for you, that we'll go through one example of how to solve one problem. But the general idea with the lesson materials for lesson number 3 was to talk about some kind of, I would call them basic concepts in terms of programming, which doesn't necessarily mean they're easy, but they're fundamental. They're things that pretty much everyone who writes some form of code uses regularly, and these are for loops and conditional statements, as I've already mentioned previously. Now, the idea with for loops is that it's very often the case that you have things where you maybe have a list of values and you want to go through and repeat some operation on that list. So I actually was thinking I could try to make a simple example here before we look at exercise number 3 of some latitudes of different cities in Finland, and then we could go through and do a calculation of how far north or south they are from some arbitrary reference point. So this is kind of a not totally fake example, because you might think of doing something like going through and calculating the deviation of some, I don't know, like an isotope measurement from some expected value. Find out how far it is away from the expectation. So we can start here by just putting in some kind of reference latitude which we'll just call ref latitude of, in this case, let's say 61.0. I don't know, just doesn't really make a big difference here. So we can define a variable called ref latitude and set it equal to 61. And then we need a list of latitudes. And since it's a list, we're going to put this in square brackets. And I'm going to look off screen here for a second to some of the latitudes that I have. I think actually what we'll do is we'll make a list of cities at the same time. And our cities list will make, of course, number 1, Turku, and then Tampere. Let's go with, how about Oulu? Oops. And we should get Helsinki in the list, and then maybe Kuopio. So we have our 5 cities here, and the next thing we're going to do is we're going to list the latitude. Of course, we could list latitude, longitude, elevation, whatever, all this information for each of these cities, but we're going to keep it simple and just do latitude. So latitude for Turku is like 60.45 according to some website I found. Tampere is 61.50. Oops, I'm not on the right screen. And Oulu is going to be a bit further north, of course, so that's 65.01. And Helsinki is a little bit further to the south, 60.17. And finally, Kuopio, we're going to go back north a bit to 62.89. So the idea here is that we have 2 lists of cities and of latitudes of those cities, and then we have some reference latitude that we're going to use just to figure out, actually, you know what, let's make this reference latitude something more meaningful now that I'm thinking about it. Let's pick another city that's somewhere like, how about Pori? Let's go with Pori since it's sort of kind of central. And the reference latitude we'll use for Pori then is 61.48. So what we can do here in this example, and I'll just put a note here, this is for Pori. What we can do in this example is we'll just go through and calculate what the number of degrees north or south of this reference latitude is. As you can see, this is quite similar already in some respects to problem 3 of exercise number 3. But I'm going to run this cell first, so I'll just define these few variables and lists. And then we need to think about how we're going to approach this. And so to me, the logical approach here is that we have some list of cities and latitudes. They're both of the same length, and we should take advantage of that. And we want to go through to each one and say for each city, how far north or south of Pori is this city? And we can actually, since we're doing this, we'll add a print statement in here and everything, and we'll make this kind of give us some useful information. So to go through the cities, we're going to use a for loop, and we'll say for city, or actually, let's do it this way. Let's do for I in range of length of cities. So what we're going to do here is we want to just assign some number here, I, which is going to act as our index value in these 2 lists of cities and latitudes. The reason we want to do it this way is that we have a list of cities and a list of latitudes, and at each location in those lists, like location number 2 in the cities list is Tampere, and we have the latitude at the corresponding location number 2 in the list of latitudes. Now, I'll remind you that for the indexing and for the references of where these things are in our lists, we have to think that indexes start at 0 in Python lists. So Tampere is actually going to be at index 1 even though it's the second thing in the list. And same thing, its latitude would be at index 1 in the latitudes list. My for loop is going to basically allow me to go through some list of cities and go to each one and do something. So what we want to do is we're going to make a range of numbers that we'll do using this range function. How many numbers do we want? Well, we want the same number of numbers in this list from the range function as we do have in the length of our list of cities or latitudes. So this len cities is going to give us back a number of 5, and then if we do range with 5, we're going to get 5 index values back as what values will be given to I, our variable here. So I can kind of go back and review this after we've done some things here just to make sure it's totally clear. But we now have our lists here. We have our reference latitude. So maybe the first thing we want to do is calculate for a given point, are we north or south of the reference latitude? We could make this kind of complicated, or we can kind of make it simple. I think we'll do the simple case here, and we'll do something a little more complicated for problem 3 and exercise number 3. So we won't worry about saying whether we're north or south in terms of dividing things here. We're just going to first calculate for this latitude value that we have for one of our cities, how different is it from the reference latitude? And so we'll make a variable here called latitude difference, or latitude diff. And our latitude difference is simply going to be the latitude of the city minus the latitude of Pori. So this is going to be latitude of our city, so latitudes of I. So we want to take one city out of this list of cities. So we're going to take the one that is at location I. And remember that I is going to be some number from 0, in this case 0 to 4. And we're going to take whatever the latitude value is for that city and subtract from it our reference latitude. So that's the latitude of Pori in this case. So we're going to get some number back from this. If we think about the first city, we have Turku. We're going to have our latitude here minus some bigger number. So we're going to get a negative result from this for our latitude difference, which tells us in this case that we're south of Pori. I guess perhaps that's not really sort of new information to you. Once we've calculated this, we can have a print statement in here, and we can say that, let's say, oops, I'll use maybe single quotes here, the city of, and then we can put in here, oops, our cities, again, using our cities list and whatever city I is, so whatever value we have in our for loop. The city of that, oops, I'm accidentally zooming in here, is, and then we're going to add in here another piece to our string. We have to use the string conversion command, this str, because what we're going to report now is our value for latitude diff that we have here. So I'm just going to copy that here and add it in here. So the city of whatever city is some difference in latitude, and I'm going to say north of Pori. Now the reason I'm saying north is because when we've calculated our latitudes here, anything that's a negative number will be south of the value. So we're going to have some minus degrees north of Pori. Okay, we could make this a bit nicer if we wanted to use some conditional statements in there to calculate whether we're north or south and then print out something different. But like I said, we'll keep it a little bit simple here. So we calculate the latitude difference for each one of the cities. So each time we go through, we calculate a new value for this latitude difference, and then we print out the city of whatever city is this latitude difference north of Pori. Pretty pretty straightforward in some respect. So I'm going to run this and then we'll see what we get out. Okay, we got kind of ugly output here because of the numbers are, could be, could do some string formatting, make things look a little bit nicer. But the city of Turku is minus 1.03. Oops, I didn't put degrees in here. So let's put degrees in there, run this again. Okay, nothing big difference. The city of Turku is 1.03 degrees north of Pori, minus in this case, right? So we know it's south. Tampere, almost the same latitude as Pori. Oulu is about 3.5 degrees further north. Helsinki is about 1.3 degrees further south. And Kuopio is about 1.4 degrees north of Pori. Maybe it's not the most useful thing to have done, but we've gone through and we've basically used, in this case, a couple different lists. And we've gone to each city, calculated how far north or south it is from Pori, and then printed that out to the screen. And you could think of examples of doing similar things, maybe not using latitude and longitude of cities, but maybe you want to sort of use depths where you've collected samples or some kind of other spatial distribution of where rock samples have been collected. And you can certainly do this more nicely for natural choices of examples of things that you actually want to do. Now, I'll do maybe one thing here. I guess I haven't really planned out too much what to do in general today. I'm just going to copy and paste this cell here and remind you of how to make your output look nice in these things like print statements in Python. If you're not into this and you're not at the stage where you're like, I want to make my output look nice, but I just want to kind of have some meaningful output, that's fine. I'll just show this quickly and then we can move on to something else, because there are some ways in which we can make things look a bit nicer in Python output. First one, what I'll do is I'm going to replace this section here where I have this string latitude diff with something that will, in its place, allow me to have a little bit nicer formatting of my output. So I'm going to delete this and I'm going to put in here a couple of these curly brackets, and I'll explain this. I can't remember whether we've gone through string formatting. I think maybe we have seen this already once, but I'll explain what this means in just a second. So I'm going to replace that latitude difference with some funny looking thing here, and I'm going to replace the city over here with some other funny looking thing like this. What these are kind of placeholders for where you want to format some kind of output. And so the way you do it, when you put these little curly brackets in, 0 is going to be the first thing where you want to format some output. 1 is going to be the second thing where you want to format some output. The indexing works kind of like Python lists. You put some stuff inside quotation marks like we've done here, and then you add this dot format method here. And what dot format should include is then the list of values that you want to have formatted in your statement. So we had before cities and cities of I. So each time we pass through here, it's going to go to this place in our print statement and substitute in the value cities of I. We haven't specified anything other than this should just be the first item that's in the list of variables here. So we haven't given any kind of detailed formatting information, and don't worry about that for right now. The other thing we want to do is I'm going to just copy our latitude diff. That's the second value we want to have here. And so the second value will get substituted in here as latitude diff. And that's why there's a 1 here, because it's the second item in the list of values. And I have given some formatting information here. I've given this point to F. So F says that we want to have a floating point number. So in other words, we want a decimal value. And the point 2 says we want 2 numbers after the decimal place. Now, if I run that, I get something that looks a little bit nicer. Doesn't look a whole lot different. I mean, as far as putting in the city here, everything looks basically the same. I've just decided to use this string formatting just to get a little bit nicer looking output. But obviously rounding your numbers to 2 decimal places, especially if you're printing out things that you want to have kind of like table-like output, you often want to say, okay, I only want a certain number of decimal places. And you don't want to suggest, for instance, here that we have, some 12 or 15 digits of precision in this calculation when we don't. We have basically 2 values after the decimal place for both our reference latitude and the latitudes of the cities. So it doesn't make any sense. All these numbers here are just the fact that when you subtract values in basically on most programming languages, you don't get always an exact value back, but something where there's very close to what you're looking for with a whole bunch of decimal places of tiny stuff after that. So anyway, I can't remember again whether we've done this string formatting stuff yet, but if not, you'll eventually see something like this. If so, because this is really weird, like the kind of way in which the string formatting works, I think it's actually better than it used to be. There was an earlier format in Python that I thought was actually worse. But this is still kind of awkward enough that it takes a little bit of practice. After a while, it kind of becomes like natural, but for right now, perhaps it would be a bit awkward. Okay, so let's go here then. I guess if there's questions, maybe you can post those in Slack. I guess I'm going to assume that example was sort of clear. And again, since this is the YouTube stream, you can always go back and watch it again if you're confused. But let's go here to problem number 3 for exercise number 3. And if I see any comments or questions that pop up in Slack, I'll jump back and respond to those. I don't know how much. We've probably got about 10 seconds of time delay here between me and what you're seeing. So for this problem number 3, we're dealing with a pretty similar problem actually, and that is that we just want to take some reference latitude and longitude in this case, and then classify cities as either being northwest, northeast, southwest, or southeast of the center, I guess, quote unquote center of Finland, which falls pretty much right on top of one of these FMI observation stations. That, of course, causes a bit of trouble, as we'll likely encounter as we go through the exercise. But the point here is that we just simply want to take all of these cities and say, okay, well, we know the latitude and longitude, but is it in the southwest part of Finland or southeast? And of course, these geographical regions are strictly on the basis of latitude and longitude, not corresponding to what people actually call southwest or southeast in the country. So, the problem is basically laid out here, that we've got these 4 geographical regions: northwest, northeast, southwest, southeast. We know that. And we want to go through and go to each one and check to see, are you north or south of the reference latitude? Are you east or west of the reference longitude? And then on that basis, give you some classification. So that's the general idea, and I think we'll do the north-south test first, and then we'll do the east-west test after that, and then once we know which location we're in, we can append that value to some list, and then at the end we'll print things out. So here's what you're given. You're given a bunch of stations. I don't remember how many. Some 34, I guess. You've got a list that's already got all these stations in it. You've got a list of all their latitudes and longitudes, so that's nice. Saves you a bit of work. And you've got the north-south cutoff and the east-west cutoff. So basically all you have to do is just run this cell to get that information into memory so it's available for us to start working. The next job is then to create these lists. And we're going to make some empty lists, so that's not really a big deal. So we need something called northwest, and we'll say northwest equals some empty brackets. And then because I'm lazy, I'm going to copy and paste all of these things. We know we're going to need a northeast, so we'll make northeast. And then we're going to need a southwest, so we'll make southwest, and we're going to need a southeast. So not too bad. All we're doing is just making these variables as empty lists, and that's pretty much all we need to do there. Just define the name and set it equal to a pair of these square brackets that have nothing in them. And this test print should work. Well, okay. We get back empty lists. Not a big surprise. I guess the main point here is that you've used the right variable names as they're described above there. All right, so we have our lists. Now, the next step, count the number of stations and store that value in the variable called n. Now, there's actually quite a number of ways in which you could approach this problem. We know we have some variable called stations here. If I look at the length of stations, I see it's 34. I remember from the description we had 34 stations, so this seems like maybe it's the easiest way to approach this. And so we can just say capital N is equal to len of stations. Anytime you have a list and you use the len function, it gives you back the length of the list. When we get to using NumPy or pandas, there are other ways to find out lengths of the data structures that are used in those libraries. So NumPy, they have these NumPy arrays, and you can find their length in different ways. But for something in a list, we can use len, and we could say n is equal to len of stations, and then our print statement here. In the data, there are 34 stations, appears to work as expected. So that's good. Now, we're getting into the heavy lifting. We have to make a loop that iterates over n, or iterates n times, and then divides the stations into these different geographical areas. So we got to think about this a little bit. First off, we know we want to go and look at each station's latitude and longitude. We have the lists that we defined up here of lats and longs, and we're going to want to go through in our code and do the same analysis to each one of these stations. This is the reason for using a for loop. We could go and do the calculation manually, and for each station say, what is the latitude? Calculate whether it's north or south. What's the longitude? Calculate whether it's east or west of the reference cutoff values, and then classify things manually. But the whole point of doing these kind of things with a computer program is that we can come up with the idea of how to do this once and then do it for all 34 stations the same way, so that you don't have to go back and type everything in 34 times. Each time you type that stuff in to calculate by hand whether the latitude and longitude put you in northeast or southwest, every time you do that, there's a chance you make a mistake in typing it in. And the fewer mistakes you can commit and in doing this kind of processing with this kind of data, the better. Because let's face it, a lot of the stuff we've been doing up to this point, you're probably going, I could do this in Excel. We've got 34 stations here, but if you start dealing with much larger data sets, so if you're dealing with hourly temperatures for the last 100 years, all of a sudden you've got thousands, if not millions, of data values, and you're certainly not going to want to do that by hand. And even if you have smaller numbers of values, you probably don't want to be typing these things in to check the latitude and longitude each time one by one. So that's kind of the logic here with using this for loop in general, is to go to each point where we want to do the same kind of analysis and do it the same way with this sort of repeated set of operations. So there's a comment here that if you make a mistake, then the mistake will be replicated for all 100 or 100 million values. That's absolutely true. So if you make a for loop and you do your for loop incorrectly, then all of your analysis is going to be wrong. But most likely, if you were to do it one by one, you would be making the same mistake. So there is a step in here where we have to sort of do a little bit of a check to see, does our code actually seem to work the way we expect it to? And this is a pretty common thing that you would do in general. You run your code and then you check and say, did that actually do something that looks meaningful? Is the answer correct? We talked about this, I think, in lesson number 4 when we deal with functions, that when we create a function to convert temperature from Fahrenheit to Celsius or the other way, we want to put in some values that we know so that when we run the function, we can check to see that the output is correct. So the same thing works in a for loop. We want to, after we do this, check and say, like, do these different points appear to be classified the right way? And we can do that, fortunately, without too much trouble. So let's take our loop here. We know that n is the length of the number of stations. We want a loop that iterates n times. Okay, so we could do this with a for, and I'm going to again use the variable letter I to be our index value in this case for I in range. And since we've already dealt with the calculation of how long this list is, we can just put our variable n in there. So for I in range n, we're going to do some stuff. I see a question here about exercise number 5 in NumPy, and I'll come back to that in just a couple minutes once we get through this. But yeah, for I in range n, so again, we know we're going to get a list of numbers out of the range function. That list will be 34 values long because that's how big the value of n is. We want to do some stuff. And first we want to check to see whether we're north or south of this cutoff value. So for each one of the values of latitude, we want to check and see whether it's bigger or smaller than this cutoff value. Looks like we got a question here about the for loop, so maybe I'll pause for just a second. Variable I in the loop, if we replace the variable city, for example, is it always obligatory to mention city inside the loop as well? Yeah, so I mean, I guess if I just jump back to our other example for a second here, the value of I, if we print it out inside here, so I'll just print I in here. So I've commented out our printing out of this nice information about the different cities, and all we're going to do is print out the value of I. So when we go through the loop, each time, first time through I is equal to 0, next time I is equal to 1, then 2, 3, 4. Okay, that kind of makes sense. And if we called this instead of I city and printed city in here, we'd get exactly the same output. Whatever we call this variable doesn't really matter. All it's going to do is take the values in some list, in this case it's a list of numbers, and assign the first value to city the first time the loop runs. Then the second time through it, we'll get the second value, third time through, etc. Now, if you wanted to do the loop in such a way that you said for city instead of range len cities, just simply cities, now, I'm just going to comment out this other line here, we're going to get different output because we're looping directly over the values in the list. So instead of using the index for the value in the list, we're just going to get the values of the cities themselves. So here for city in cities, print city, and then we go through each one, Turku, Tampere, Oulu, Helsinki, Kuopio, and printing out each one of those cities to the screen. Now, the reason that I didn't do it this way in this example is the fact that we have both the city and its latitude that we want to reference inside the loop. So we know we can use the index to find the value at position 0 in the list of cities and the corresponding value at position 0 in the list of latitudes. So that's part of the reason why, depending on what you're doing with your for loop, you might approach it a little bit differently. If you've got two lists of the same size and you want to refer to values in both of them, it's usually best to do this for I in range, len, and then some one of the lists. If you just want to do something like this, print out some statement that says, my favorite city is, and then because we want to refer to the variable city, we're going to end our quotation marks so that it doesn't try to print the word city, but instead refers to that variable. You could make that modification to say, my favorite city is whatever. Again, we're doing directly iterating over the values in this list. It's not as easy at this point then to say like what the latitude is for these different cities, because now if you wanted to do that kind of after deciding I must loop directly over this list of cities, you're going to have to do something kind of clumsy, like in here figure out where the city is that you've printed in the list of cities, find its index, and then use that to print out the latitude. It's kind of a clumsy way to do it, so it's easier to just simply use the range function. Let me read the question here once again to make sure that I've kind of covered that. So yeah, I guess the other thing is that like the variable I has been defined in memory inside this for loop. So after the for loop finishes running, it is still defined in memory. It's not like it's been forgotten. But if we said here for city in cities and then just print I, we're going to get the number 4 printed out 5 times, I guess, because that's how many times we're going to go through and try to do something about cities. So inside here, we don't actually reference this variable called cities at all. And you don't necessarily need to. It would be kind of unusual not to reference that variable, but in principle, you don't necessarily need to do it. But what you see here, whether you do it like for city in cities or for city in range of length cities, so the kind of earlier approach we were taking, I get the same output. The difference here is that the numbers out of this range function are still getting assigned to a variable called city. And since there are 5 values in this list, this print statement is going to happen 5 times. So it's it's printing out something kind of meaningless in this case, but it at least is working. So yeah, I think that's a good question, and I see comments from the instructors there that they also recognize that was a good and important question. Hopefully that makes things a little bit more clear. If not, you can post back in Slack. In the interest of time, I'm going to jump back here because I'm kind of needing to finish up not too long from now. So I would like to finish going through at least this exercise 3, problem 3. Regarding the question about exercise number 5, I may have to come back to answering that in Slack later. We'll see how things are looking, but yeah, let's go back here. I think we're kind of going a lot of different directions, and hopefully you can follow. But let's jump back here to problem number 3, where we were in the early stages of our for loop to go through all of the different stations that we have and to classify them north or south of these cutoff points. So we've got our for loop that's going to take us through the number of stations that we have. And our next step is to add in some logic here about choosing whether we're north or south of some reference latitude, I guess, in this case. So we'll do the north-south cutoff first. So we have an if statement, and our condition is to say that if the latitude of this current station, so if, I think it was called lats, yep. So if lats is greater than the north-south cutoff, so that was our variable name here for the latitude where we decide that things are either northern or southern. So if the latitude is greater than north-south cutoff, that means it's north of the cutoff line, then we know that we're north of the cutoff line. And we could even add a comment here. We're north of the cutoff. So then, if we know that we're north of the cutoff, our next step is to decide, are we east or west of the cutoff. We could do this sort of separately if we wanted to. We can do it together. With this problem, there's several different ways you can solve it. Generally, we want to try to minimize the amount of times that we're like copying and pasting code, but it's also sometimes easier to understand the code if it's written out in a kind of logical way. And I'm going to take that approach here, and I'll note that there are several different ways in which you could do this. If someone told me I could not do things this way, I would be able to come up with an alternative solution. But if we know we're north, our next check can then be to say, is the longitude, so oops, I've made a mistake here. This should be lats of I, so latitude for the current point. And if lons of I, same kind of idea, is greater than, I guess it's going to be our east-west cutoff. So just copy paste that in there. Then we know we are, if our longitude is greater than our east-west cutoff, that means that we are to the east of the point of interest here. So right, our latitude or longitude rather is increasing to the east from 0. So we know that we're in the east if our longitude of the given point. This is probably turning into a disaster that I'm mixing these up, but we are east of the cutoff. Once we know that we are north and we know that we are east, then we can say, well, for this point, we should append whatever the name of this station is to our northeast list. So we have our northeast list here, and we can append to that, what is it called? I guess it's going to be stations of I. So for this station in the list at index position I, we know that we're north and east, so we can add that station to the list. We have a little bit of extra information here. I guess, hopefully that part sort of makes sense. If not, you can add some questions while I continue here. So we have this condition that we know we're east. Well, if we aren't east of the cutoff, then we have to be west. There's only two possibilities here. So we have this else condition here that is, if we're not to the east, then we go to the condition. Remember that these if statements check to see if something is true or false. So we check for the longitude of the current point, whether it is greater than east-west cutoff. That's either true or it's not true. If it's true, then we do the stuff that's down beneath the if statement. If it's false, we go to the else condition here, which means that we are west of the cutoff. And if we're west of the cutoff, we still know that we're north. I'm just going to copy paste because I'm, again, lazy. We know that we're north because we've passed the condition of being north of the north-south cutoff. And so If we're in the north and we're west of the cutoff, then we have to be in the northwest area. Now, again, you could do this a couple different ways. I'm going to go for what I see as the kind of simplest solution. We've done the testing here for the either possibility of north and south, of north of the line of being either east or west. But if we go back here, we still have to deal with this condition that if we say that our latitude is not greater than the north-south cutoff, which means we're south of the line, so that we can cover with our else condition. Here we know that we are south of the cutoff. And if we're south of the cutoff, we can actually apply pretty much the same logic that we did above and steal this stuff and then do a little bit of editing. So I'm just copying this check to see if we're east or west, because we can apply the same basic logic here, that if we're south of the cutoff, we still have to check for the longitude of this point. Is it east or west? And if we have a longitude that's greater than the east-west cutoff, that means that we must be east of the cutoff. And so we should append something to the list. But in this case, remember that we are south and east. So we want to have this be our southeast append. And of course, following the same logic, you could then say that the southwest append would happen for the other case there. So to me, this is one possible way to approach the problem. There's a couple questions that might come up in here in your minds. One of them could be, well, we've checked to see if we're greater than the north-south cutoff, but what about doing greater than or equal to the north-south cutoff? Because as it turns out, we've got one nasty station. Our nasty station is in the list of latitudes. You can see it here, 64.5. Our north-south cutoff is at 64.5. This, I think, is, I don't remember which station it is, but it's one that causes a little bit of trouble because its latitude is equal to the cutoff value. And depending on how you've made this test, if you said it was greater than or equal to, it would be classified differently. If you said that the latitude should be greater than or equal to the north-south cutoff, that station would be seen as being in the north. If you said the latitude has to be greater than the north-south cutoff, that station's not seen as being in the north because its latitude is not greater than 64.5. It's equal to 64.5, which means it gets classified as a station in the south. As far as I understood from some of the feedback in Slack, this is something that did come up in some cases, that people had different numbers of values in their lists because of this exact issue. This is a basic kind of logic thing, and it's a common problem actually to encounter. These tests of, should I check to see if this is greater than or equal to some value? And it's kind of up to you depending on the problem that you're solving. The important thing, I think, for the graders to know, and for you folks who are doing this exercise, is that you're doing it the right way. The main thing here is to allow you to apply for loops and to do these conditional statements, if, else. And if you did this, with greater than or equal to, or just greater than, I don't think it makes any difference as far as I'm concerned. It will screw up the auto grading because the auto grading has one expected solution, and frankly, we should remove this one station from the exercise, or change the cutoff so that we don't have this problem in the future. Because I think many of you may have done this correctly, but then the auto grader takes away a point because it sees the solution as being different than the expected one. Okay, so I'm already running a little bit over the time because I like to talk about this kind of stuff, but let's run this code. Let's run our little example that we've just done here. And oops, I've got syntax errors, right? I should have for I in range n, not just for I range n. So oops, hopefully that's the only one. Looks like that's the only syntax error. Code could be wrong, but now we should be able to run these tests down here for these different cells. In the following cells, you should print out the correct names for each geographical zone. And we have given you the correct number of stations as a hint for each zone. And the names of the northwest stations are these 4 here. So that looks good. We're supposed to have 4 stations, and we have 4 stations. We're expecting 2 stations for the northeast. We have 2 stations for the northeast. Things are looking good so far. When we run the same thing for the southwest stations, we have 16, and looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 stations there. And lastly, for the southeast, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 stations there as well. So it looks like our for loop works the way we expect. In this case, we have a solution that's an expected solution with the number of stations we have here. And we could also go and check that this makes sense. Of course, having a slightly skewed distribution to more stations that's south of this cutoff line makes sense, because more of the population in Finland lives south of 64.5 degrees than north. So we should expect our station distribution also to reflect that a little bit. But we could also look at the map and say, okay, it looks like there's 2 stations that are showing up in the northeast. And if we scroll back up, we see here 1, 2 stations showing up in the northeast, 4 stations in the northwest, 1, 2, 3, 4 stations showing up there. So you could check this answer in a couple different ways to see whether things worked correctly. Now, just as a thought experiment, or just to demonstrate, if we changed all of our greater thans to greater than or equal to's, we're going to get different results. So I've just changed all these to greater than or equal to, run the code again, and now I've got an expectation. Oops, I have to reset my lists because I've appended a second time. So let's run this again. So northwest, I still have 4 stations. Northeast, now I have 3. I expected 2. And the reason is because now we have this, I guess it's Vala Pelso, that's the extra station that is right on that north-south cutoff line. When we use the greater than or equal to test to see if it's north or south, now it gets classified as north of the cutoff instead of south like it was previously. So that's, if you encountered that problem, my guess is that that's what happened. And the thought here perhaps is not totally clear in the explanation of the exercise, is that you would use greater than to check the latitude first. There's of course several different approaches that could work for this. But I think that's essentially what I wanted to cover for this exercise 3, problem 3. The question on the stuff for NumPy, I'm going to have to come back to. I think it's going to take a bit too much to get into this. So maybe I'll try to answer in Slack. There was a question about exercise 5, about keeping lists and other things like the data that you're calculating intact when you do some calculations of various things from those lists. So, calculating mean values or slicing out certain selected ranges of values from the lists. We'll have to come back to that one, unfortunately. So I can answer in Slack, and if it seems like there's still some uncertainty in Slack in the discussion there, then we can also come back to this maybe next week. And I didn't really get into functions either, so I guess did for loops and conditional statements in a bit of detail, so that chewed up the time pretty quickly. So sorry about that, but I guess it's probably good in a sense that we did take the time to go through in detail, because these are sort of, as I mentioned when we first started talking, these are kind of fundamental pieces. These are like the building blocks of what you're going to use later. So for loops are likely still to cause some confusion later on. Even when you get to the lessons 6 and 7, you might still be a little bit confused sometimes about the for loops. But hopefully this clarifies things a bit, and as you work with them more, I think you'll find that they become more intuitive as you get more experience. So yeah, I'm sorry that I don't have much more time today. Well, it's just a busy week this week, so I think we need to maybe leave it here. And if there are other questions that you would like to follow up in, for the question on exercise 5 in Slack, I can try to get to that this evening to give some kind of at least quick comments there. And if you have other questions, you're always welcome to post them in Slack, and either myself or one of the instructors will attempt to give you some kind of answer there. So yeah, I think that's it for today, and I think we should be able to continue normal time next week. It looks like I finally figured out this scheduling a YouTube live stream thing, so I'll do the same for next week and put the link in Slack when that's ready to go. All right, so I haven't been monitoring the stream quality, so hopefully looks like everything is kind of okay. And yeah, I think that's it. So I will maybe talk to you folks, talk to you next week. Okay?